Welcome back, guys. My name is Angel. Today's episode of That Plus Plus, we're gonna be talking about system design and dependency injection. So let's dip right in. So this is what we're gonna see today. What is dependency injection? The goals of DI, principles behind dependency injection, including components, responsibilities, strategy, some pros and cons, and a very basic example on TypeScript. So this will take us around 15 minutes of your time, so stay tuned. So, right, what is dependency injection? This is the definition right out of Wikipedia, right? In software engineering, dependency injection is a design pattern. This is a very important thing to know. This is a pattern that is used everywhere on the software, industry. Desktop, web, servers, in which an object and a function receive other objects that it depends, right? So, a form of inversion of control, dependency injection aims to separate the concerns of constructing the objects and using them, leading to loosely coupled programs, right? This is a little bit complex definition. It doesn't give you too much information about what it is and how to implement it, but in a very summarized way or simplified way, what basically dependency injection is in order to construct complex objects and his dependencies, you rely on a centralized component that does that for you. Instead of having to implement in each one of the classes or in each one of the objects, how you're gonna, instantiate, this class or this class or this object if you're gonna need it for your internal use, right? So with that in mind, I designed like my own definition of dependency injection, right? Of course, it's a design pattern. There is no objection there. For me, is for an object-oriented programming, right? This is really rare to see it in functional, programming or any other types of paradigms, in which the creation of use of objects instances are completely decoupled or separated, right? With four specific goals in mind. That's what I'm listing here. First of all, abstracting complex object instantiation, meaning that let's say that we need an object, kind of like a database connection, for example, that we need to use everywhere in our system. Imagine to have to, like import the variables, create a database or create a database connection, select the database, set up things like the character set or the chart set or the pool configuration and a lot of stuff. So instead, you centralize that implementation and then you provide a mechanism for any other classes that need that connection to just simply receive it or have it there, right? With that being said, the directly consequence of that is reducing the boilerplate code, meaning that all those instantiation procedures that you have to do, you have it in one place and you just reuse it through a component of the pattern that is called the injector, who is the responsible of injecting those instances where they should be, right? Third, you control the object creation and distribution, meaning that you generalize the way that you construct the object, or if you want to specify, you create like the exact specification for it, and also you control the distribution, right? Very common pattern or also sitting the database connection is that some strategy for drivers, designing connection pools, they relied on objects, taking care of that connection or each one of the connections that the connection pool can do to a database, right? So by defining in the injector how many connections does the pool has available, you control that delegation, that creation of objects and availability of connections, right? Lastly, creating an homogeneous strategy of managing dependencies between components of the system. This means that as you start creating services, specifically in large system or where you are working with multiple programmers, this tends to, dependencies and how you create it tends to get out of control, right? Everybody is creating objects everywhere. And what this does is, create a pattern, a convention, and a strategy for always injecting objects in the same way everywhere. That way your code looks better, it's easier to debug, and it's just better overall. So some principles and DI, right? The components. Normally, diagrams that show the components of dependency injection, they show like 3 or 4 different components. I'm exposing here 4, right? And let me explain those to you. First of all, we have the client, whoever is trying to use a service, right? Or do an action on the system. This could be an incoming request. This could be a script that is using the system. This could be literally anything, right? The client uses the injector in order to create a service instance, right? The injector is the responsible. It's kind of like your service directory, right? And the injector knows everybody, and he knows how to create a service and how to inject the dependencies of those services, right? Those dependencies of the service are called injectables, right? Basically are utility classes or other services that they are declared as a dependency of on a specific service, right? Everything is done with an injector. You register through the injector. We're going to see that, and then the service is the class who actually is going to do the business logic, or who's actually going to do the job, of course, with the help of the injectables. So responsibilities, again, the client instantiates services using the injector. The service has the responsibility of registering himself with the injector, or the injector has a way of discovering all the available services. Same thing with the injectables. The injectables need to tell the injector where they belong, what are their dependencies, or the injector has to provide a mechanism to discover all the injectables and where they should be inserted, right? That's part of building that pattern, right? So talking about strategies, right? Strategies for instantiation of services by the injector. It could be just registering the class or registering the name. Remember, the injector can discover all the services, or someone can tell him like, hey, you have this service and these are the dependencies, right? For the specific job of injecting the dependencies, a common strategy is to using a constructor or a factory method. Basically, the constructor receives all the dependency and he is in charge of assigning what is where. Or you use a factory method, right? You keep the constructor for a specific use, maybe some other use, and then you create your factory method in order to create an instance of that object with the specifications that the injector requires, right? You could also use setters or property, basically creating the object and assigning directly, the injectables. Okay, pros and cons, right? Just summarizing the benefits and the disadvantages of using dependency injection, right? First of all, let's talk about decoupling, right? By decoupling, your application, services and injectables, they communicate to each other in a simpler way, right? When you're going to create a business logic method, you assume that all your dependencies, injectables, are there already. So you don't have to bother with complex instantiation, right? By doing that, the extending or changing methods, it becomes simpler, right? It becomes less cumbersome just because you don't rely really in instantiation and importing stuff and going here and there, right? One of the cons, however, in decoupling too much or using decoupling the system by using this strategy is that the creation of objects, it start becoming really complex on the injector. Why? Because you have to take in consideration all the possible use cases in the scenarios where the service are going to use the injectable, right? So if you start to adding information to an injectable to a service to do more stuff, then the injector gets increased on complexity because he needs to start taking in consideration all those type of scenarios or all those type of variables and conditions in order to execute, right? One other cons of decoupling this, I didn't put it there, is that you are not able to configure or change the state on a specific service easily, right? You either have to recreate a service with a different configuration, or it could become really cumbersome and it loses the purpose of dependency injection. Is that in your business logics on the service, you start tweaking here and there the injectables, right? Which again defeats the purpose of dependency injection overall, right? Next one, complexity in implementation, right? It is one of the simplest patterns to understand and is very broadly used. So you can find it like in multiple places. You can check the libraries that you're using right now. There's a chance that you're using a couple of libraries that use dependency injection. That's a good thing, right? The bad thing is that as is something simple that you can implement yourself, you can also reach scenarios where that implementation is not the optimal implementation. You can abuse like reflection, generic typing or dynamic typing or doc typing, or abuse the use of masquerading or hiding errors just because you have to take in consideration multiple scenarios where your injectables are going to be used, right? Also, in highly concurrent environments such as the connection pool that I was describing, the injector becomes like a really complicated piece of software, right? You have to use semaphores, traffic, kind of like traffic lights, logs, pools, and that sort of stuff, which it can get really nasty when you're trying to limit the use of objects or control the supply of different instances, right? Testing probably is one of the most pros that makes the use of dependency injection, is that when you centralize in a single component the creation of objects and how they depend into each other, then testing becomes really easy, because you can test unit testing becomes really easy because you can test independently injectables and services in a more complex environment by just mocking or patching the structure that the injector has, right? Also, that's one of the cons, right? In a scenario where the injector is really complex and it has a lot of logic, simply mocking or patching the injector is not going to be enough. You're also going to have to start like creating your own tests for testing the injector, right? Good, perfect. So let's go with the example, right? Let me open my WebStorm. So I did a very basic, example, right? Let's put the client here just in the structure that we have in the presentation. Oh, sorry, this is the injector, and this is the injectable. Let's assume that we want to execute, an operation called calculate balance, right? Let's say that we're a bank, or that we are a web application who is summarizing different sources of data in order to give you a balance of your account, right? And it does that through a class called balance service, right? So first of all, we define the client. Let's assume for now this is a very simplified version of an Express application. And what we're gonna do is, I'm gonna tell like, if someone hits this route, let's call this balance route, right? Just to give a little bit of context. So in the balance, the client uses the injector to create a balance service and assign the balance service to get this request, right? So how does the injector looks like, right? The injector has fundamentally two different methods, right? It has an internal variables to call our directory or list of available services, and it has a method for registering new service. Remember, the injector has to provide a way of knowing which ones are the services and which dependencies does that service has, right? And then it has a create method for precisely given a specific service, creating all the dependencies and just return a new instance of that service, right? This could be really complex, as I was telling you. This is a very simple example just to show you how this pattern works and interacts with each other, right? Then we have a service class, right, which in the constructor defines like all the injectables, right? Again, in this structure is commonly to interchange injectables and services, meaning that there are classes who will be both services and injectables, right? Sometimes not, sometimes it would, right? So we define the constructor, which is the way that the injector is going to send the dependencies. And we also, after we create the valence service, after we define the valence service, we tell the injector, hey, this valence service has these dependencies, right? And finally, we have the injectable, which are, just for simplicity, I didn't put any code here, but these could be like database connections, Stripe connections, and different types of structures that they will hide the complexity of how they interact and work, just to provide the unique services to the valence service and also to the injector in order to make it easier to create objects of that type, right? Perfect. I hope that this example really works for you guys. This is a really cool pattern. I've used it like multiple times in multiple systems. Please, if you enjoyed this video, remember to hit the like button. Put any comments if you want to see more videos like this, or if you have a comment about this specific content. Make sure to subscribe to the channel and share this with whoever you think that this information will be useful. So see you next time.